Hi, this is a continuation of the last video where we discussed the meaning of 1/3 or 4/5. Specifically, we said to understand 1/3 or 4/5, we look at the segment from 0 to 4/5. We partition it into 3 equal parts, and the length of one such part is 1/3 or 4/5. And in the last video, we calculated 1/3 or 4/5 to be 4 over 3 times 5. So in other words, the length of this piece is 4 over 3 times 5. And 2/3 of 4/5 would be the length of two such parts. So we divide this segment from 0 to 4/5 into 3 equal parts, and 2/3 would mean the concatenation of two such parts and the length of the concatenation of two parts. So we said this length is 4 over 3 times 5. So this length would be 2 times 4 over 3 times 5. And we can easily calculate that to be 8 over 15. But look at this expression. What we are saying is 2/3 of 4/5, when we understand it to be the length of two concatenated parts, when this segment is divided into 3 equal parts. If we understand it to be that way, we are saying 2/3 of 4/5 is in fact a fraction whose numerator is in fact the product of these two numbers, these two numerators 2 and 4, and its denominator is in fact the product of the denominators 3 and 5. So we'll soon consider the general scenario of a fraction of another fraction, and we'll write out a formula for it. It will have the similar structure, but let's also look at 2/3 of 4/5 using the area model. So here we have looked at 2/3 of 4/5 using the number line, and let's now look at it using the area model. So on the number line, recall that the unit segment is of length 1, and using the number line and using the definition of 2/3 of 4/5 as the length of two concatenated parts, when the segment from 0 to 4/5 is divided into 3 equal parts, using that definition, we arrived at this expression. We said 2/3 of 4/5 is in fact a fraction whose numerator is the product of these two numbers, the denominator is the product of these two numbers, and which is same as 8 over 15. Now let's try to understand 2/3 of 4/5 using area model. So in the area model, our whole is the area of the unit square. So on the number line model, on the length model, the whole was the length of the unit segment. Here our whole is the area of the unit square. A unit square is a square whose side lengths are 1. So in this area model, 4/5 is understood as in the following manner. We take the square and we divide it into 5 equal parts by area. So here it was easiest for me to partition the square into congruent parts, and congruent parts have equal area. So here it's easy to see I have partitioned this unit square into 5 equal parts. Equal here means equal by area. And 4/5 can be understood as putting together 4 of these pieces and the area of that region that's made up of 4 of these parts. So let me draw that out here. So let's put these first 4 rectangles together, and 4/5 is the area of this rectangle that you see, whose border is this black line. 2/3 of 4/5 is understood as the following. This 3 in the denominator denotes. Now let's look at this rectangle, and let's divide it into 3 equal parts by area. So we could do the division in this manner. We could do the partitioning in this manner approximately. So this black rectangle is now divided up into 1, 2, 3 parts of equal area. And now this 2 tells us consider 2 of those parts. So let me do the shading. So this. So 2/3 or 4/5 will mean the area of this shaded region. What is the area of the shaded region? So we notice that the area of the shaded region is, let's see, the shaded region consists of 2 rows of 4 rectangles. Area is 2 times 4 copies of, so here we see 2 rows of rectangles like this. And what is the area of each such rectangle? That's what I need to know, because the area is 2 times 4 of the area of each of these rectangles. Well, if I continue putting a dotted line like this, it's easy to see that the unit square is now divided up into 3 rows of 5 rectangles. That means a total of 3 times 5 rectangles. And as you can see, all the rectangles are congruent and have equal area. And so the area of those 3 times 5 rectangles altogether is 1. So the area of each one of these rectangles must be 1 over 3 times 5, because 15 of them put together give you the whole unit square whose area is 1. So what we're saying is the area of the shaded region is 2 times 4 copies of 1 over 3 times 5. And that's really 2 times 4 over 3 times 5, which is what we have here, 8 over 15. You can also think of it as the area of the shaded region is, it's 8 of these squares out of 15 of the total squares. That's really also what this is saying. So for now, I want you to remember is the following. 2/3 of 4/5, either with the number line model or the area model, you can see is a fraction whose numerator is the product of the numerators and whose denominator is the product of these 2 denominators. So what we've done in this video and in the previous video together is we have defined what we have given a mathematical interpretation for off, what off means. We said take a segment of length 4/5, partition it into 3 parts and look at 2 parts, and the length of those 2 concatenated parts is 2/3 of 4/5. That was the definition. Using the definition and mathematical reasoning, we said that length is really same as this fraction. So let's summarize all of this in a general setting using letters. Thank you.